the rapid cold booting, I think, is what really made Inferless the choice when we were looking at alternative. The other aspect of the cold boots is that it massively reduces our compute cost. For rather than having them always warm, we're probably talking about 100-fold reduction in that. Safe to say that before we used Inferless, our AI development process and integration lacked velocity with getting AI features developed and into production. So probably a good place to start is what Omi is, and that will help kind of explain our use case a bit. So we are a digital photo studio for product photography, where you have a digital twin that you can move and place in our various scenes and take really good looking photorealistic renders. So our technology stack is 3D first and then AI second. You've probably seen quite a lot of AI first product photography images that are generated where the product's logos aren't quite right, or the text is wrong, or there's 7 fingers, things like that. So when I say 3D first, I mean everything that we do on Omi is done in our 3D ray traced rendering engine. And we use all sorts of different AI models to behind the scenes to kind of accelerate, enhance, or create aspects of the 3D scene. So our use of Inferless has really gone hand in hand with the development and release of our super exciting new features, which is photo drop and photo prompt. So these are a process where you can take a photo or generate one, and we take this photo and we calculate all the surfaces, all the shadows, all the lighting, all the materials properties, all these kind of things that make up a real environment. And we integrate that into the photo so that you can seamlessly move your product around the surfaces as if this was a fully modeled 3D scene. So actually being able to generate all of those really interesting aspects or objects or properties for the scenes has been quite a journey, both in terms of kind of research and development, testing, and deployment, where we are using quite unique or uncommon models that aren't typically available elsewhere to do these kind of jobs. And yeah, that kind of complexity is why we use Inferless, because it across kind of the 3 main avenues that we do, such as research and development, testing, and kind of deployment. And for each of those, we use Inferless in a slightly different way. So for research and development, we're creating these unique models, and we want to kind of offload the compute power because these can be quite heavy. We might need 80 gigabytes of VRAM or something, so we can't run it on our home systems. So during the research and development phase, Inferless allows us to iterate really quickly with these models and have these endpoints for us to kind of test ourselves as developers. So for these kind of research models, the cold boot aspect is really nice. Like, we don't need them to be always warm. We just want to make sure that when we start work in the morning, we can spin up our latest unique model and give it a shot. The testing side at Omi is another different avenue. So because we are kind of an artistic company, we create art. So we've got a huge team of 3D artists that create the digital twins, but they also provide us feedback on all the various models because the outputs are very subjective. So the lighting might be a little bit too bright for a scene, might be too dark, shadow might be too intense, not intense enough, that kind of stuff. So as part of that testing process, we get the feedback from the artists. The artists themselves run the models, and with the models being booted from cold, the artists don't mind waiting a couple of seconds for the model to actually be booted, for us to then get the feedback. Finally, when it comes to the deployment or the production ready version of the models, once the artists are happy with them, with Inferless, all we can do is flip the switch so that the model's ready and waiting, or always warm for when the customer wants to kind of run the pipeline. So that's kind of the various ways that we use Inferless, in slightly different ways, I think. Yeah, it's probably quite a comprehensive answer, because we use it, different approaches for different goals, all while ultimately keeping the cost down of our research, testing, and deployment processes. I think it's probably safe to say that before we used Inferless, our AI development process and integration lacked velocity with getting AI features developed and into production, especially the getting into production or getting them tested side of things. As the back-end team, great as they are, would kind of handle that process. And in addition to using the back-end, their engineer time, the cold boots for the services that we were using were super terrible. Like, we're talking like 5 to 15 minutes, sometimes not even guaranteed that. So actually being able to, the research team, being able to handle all the deployments for production, and do the research in the first place, we can do all that. And we build the models, we run the models, we know the models, we know how they should run. So it that helped offload their workload, but also made the cold boots not an issue at all. And having, if we used the previous provider, having these models always warm would have really made our compute costs explode quite massively. Your guys' help on if we encounter technical issues or issues our end is really valuable. Sometimes we can miss things. Sometimes there's package incompatibilities that we don't notice. But the rapid cold booting, I think, is what really made Inferless the choice when we were looking at alternative providers for hosting these kind of models. The interface is on the web is quite nice as well, where we can see the number of API calls, how many containers we have running, so we can gauge the usage from a developer point of view, that we can then feed back to management to let them know if we need to scale things up or scale things down as well. So quite like the logs. Spend a lot of time looking into the logs, seeing what values are being created as part of this AI pipeline, and seeing what users are doing with it is pretty nice as well. Cold boots. So I think cold boots are a massive issue for what we do, especially because we're using custom models for lighting prediction, surface prediction. We have a lot of, I think the last time I counted, we probably have 5 or 6 unique models that we need to cold boot from. Whereas if you're doing a run-of-the-mill image generation process, you could probably use any image generation model that's always up and warm. But the user experience for us is really important. The customers, so when they are creating their kind of digital twins, scenes and their product photography, once they're happy with the scene and they render it, they have to already wait for it to be rendered that can it might take 2 minutes or more if it's a video. So as they already have to wait for that, we don't want to make them wait at all in the rest of the process. So having things boot up pretty rapidly makes the user experience really much more seamless for them. And the other aspect of the cold boots is that it massively reduces our compute cost. Rather than having them always warm, I'm probably talking about 100-fold reduction in compute costs compared to having the models on another provider and being warm. And the cold boot time on the other provider was kind of 5 minutes, not really useful. So having that really optimized cold boot time means that we can use Inferless and keep customers happy while keeping the costs down as well, and doing some really interesting stuff with our AI models that I don't think anyone else does. So I mentioned kind of offloading the deployment and kind of care maintenance of the models from the backend team to us as researchers. Our company is actually pretty small. We've got about 15 developers, or if you want to call them engineers, spread across front, engine, backend, and research. So we're super light. So when I first started using Infernalist, we had 1 or 2 backend engineers. So for the savings of their time was pretty significant, because if a backend engineer was working on it, then that would kind of half our backend team availability, really. So for time-wise, it saved us quite a lot, since they can stick to doing what they do, and we can handle the AI deployments. For cost-wise, I said, having these kind of models that we use, which use really quite powerful GPUs, warm all the time, would increase our total compute budget by at least 100-fold. So the cost saving is really massive. We're not doing kind of simple image generation processes. We're using really unique, really powerful models to do pretty cool things. So we need things to be quite juicy, and being able to save money on doing these cool things is what's going to make the product and the features really shine, and the research costs to stay quite low. If we use a different provider with our models always warm, we're talking about probably at least 50x, if not 100x of compute costs. It's quite a lot. Yeah, a lot. Even you having one model warm on a provider on another provider, for instance, would increase our compute above what would be considered reasonable for management, I think. Any individual team or even organization who is trying to develop or iterate on or test cutting edge features could really benefit from Inferless, especially when they want lots of different models that they want to test across different groups. They don't necessarily want the models to always be up all the time, as the user or whatever process they're testing can wait a couple of seconds for the model to boot itself. So kind of if you're kind of creating true innovation and doing using a lot of custom models, that's where I think Inferless shines, or custom pipelines that use kind of existing algorithms or existing components which aren't publicly available through API. That's where using this cold boot optimized instances that we love could really benefit from.